So I'm going to talk a little bit about Ohm's law. Yesterday we talked about the resistance of an object equaling the voltage divided by the current. If we rearrange that equation so that it's V equals IR, this is known as Ohm's law. Okay. However, it's only really indicated as Ohm's law as it refers to a material that has a constant resistance that is completely independent of the voltage. Okay, so this law really only applies if this value of R is constant. That's when something is said to obey Ohm's law. So when we talk about, okay, well, what things obey and don't obey Ohm's law, if I've got a couple different graphs that look like this of voltage versus current. If there's a nice straight line, if I rearrange this equation, voltage over current, then that would equal the resistance. So we could say that if this has a nice constant slope, then that the resistance is constant. But for something like this, a voltage versus current graph, where it's curved, well, then that means the slope at any one of those points is not the same. Therefore, the resistance is not constant. Okay, now this one is for a normal resistor, and this is for a lamp. Well, why are they different? Well, let's think about what happens to a light bulb. As it first lights up, it's still cool to the touch, but the longer the current runs through it, the hotter and hotter it gets. Well, the hotter it gets, the higher the resistance gets. So anything that obeys Ohm's law has a constant resistance and is called ohmic. Ohmic just means that the resistance of that capacitor is constant as long as the temperature of it also doesn't increase. Okay, for something that is curved like this, that's known as non-ohmic or does not obey Ohm's law, and that's because that resistance changes based on the voltage or the current, and it's generally due to increases in temperature.